Last week we talked about functions. And we learned that a function basically acts like a machine, where you put in a value into the input, it goes through the machine, and you get an output. And those inputs and outputs, or those x's and y's, create ordered pairs. And the ordered pairs, like right here, allow us to graph the function. So our goal last week was to understand what a function was, and then also, if we scroll down, to graph functions. And what we've learned is that when we're given a function, one way we can graph them is kind of like using the machine. We can create this big table right here and plug in different values into the function, get an output of a y, then take those ordered pairs and plot them. Okay, and that is one way you can graph a function. You can graph any function like that. However, what we eventually want to do, especially with linear functions, we want to be able to take this equation, this function, and we want to go right to the graph. We want to basically skip that piece right there because that's a lot of work. And there actually is a way that we can graph this function right as it is and plot it right onto the coordinate plane without having to do any of that work. So that's kind of our goal the next 2 weeks. Our goal is to be able to take a linear function and graph it without doing this big, huge chart. So in order to do that, we have to do some work first, okay? We basically have to understand what slope is. So when you hear when you think of the word slope, what comes to mind? Okay? Do you think of a mountain slope? Okay. How steep a mountain is? Do you think of a roof and how steep a roof is? Or maybe you even think of a roller coaster. If you're on a roller coaster and you're going to go up a big hill, and then how steep is that drop? And basically that's what slope is. Slope is steepness, how steep a line is. Okay, and in the real world, we use slope all the time. Like, I guess when I hear the word slope, I always think of skiing. Because when you go skiing on a mountain, you have different sizes of slopes. You have like a beginner slope, and you have an intermediate slope, and you have really difficult slopes. So obviously, if you're new to skiing, you want to go on the beginner slopes because those slopes are not as steep. They're kind of flat. Okay. And in the math world, slope basically means the same thing. We're going to take those lines and we're going to calculate the slope. But the thing is, we're not going to say, oh, that line is really steep, or, oh, it's not as steep, or it's flat. We're actually going to give it a numerical value. We can calculate it. So we can say, oh, you know what, that slope has a slope of 5. And when we see the slope is 5, we know that that's going to be pretty steep. Or we can say, oh, that line has a slope of 1/2. And then when we say 1/2, we know that that's not as steep. It's kind of flat. So in order to graph lines, we first have to understand slope and how to calculate it. And that's what we're going to do over the next couple days. But for today's lesson, basically, what we are going to learn is that there are 4 types of slope. Okay? So again, our goal today is we want to talk about these 4 types of slope. So let's talk about the first 2. Okay, the first 2 types of slopes are positive and negative. And in order to have a positive slope, your line has to be going uphill. Now, when I mean uphill, it means if you're coming in from the left, like this way, your line has to be going up. So that if you're coming from the left moving to the right, you've got to walk uphill. Now, your line could be like that. It could be really steep like this. It could also be very flat. But it's still going uphill. Okay? So that's a positive slope. Anytime you see a slope going uphill, the slope is positive. Well, negative would just be the opposite. Okay? Negative would be a slope going downhill. So you've got a line that's going this way. That means if you're walking this way and you come to this slope, you're going to be heading down. Okay? Slopes can be flat too, not as steep. Or they could be really steep. Okay? But those lines, if you're coming this way and you hit one of these lines, you're going to be going downhill. So that's the difference between positive slopes and negative slopes. Okay? Positive slopes, you're always going uphill. Negative slopes, you're always going downhill. Okay? So those are two different types of slope. Now, there are two other types. Okay? The other two types of slope are a slope of 0 and an undefined slope. A slope of 0 means that it's going to be horizontal. Okay? So a horizontal slope or a 0 slope is just going to be a horizontal line, and it can be anywhere on the coordinate plane. It can be right along the axis. Okay? But it's got to be totally horizontal, and it's going to have a slope of 0. Okay, that means it's flat. And when I think about this, you can actually ski or walk on a horizontal slope. Okay? When you ski, it's called cross-country skiing. And you can ski on this. Okay? An undefined slope is going to be vertical. And a vertical line is straight up and down. Now, can you walk on this type of slope? No, you can't. It's called falling. You're not walking, you're falling. It's like a cliff. It's a drop-off. Okay, so any type of line that is horizontal is going to be an undefined slope, meaning there is no slope. Okay, that is different than 0. 0 is an actual number, and you can have a slope of 0. Undefined means no slope. Okay, so that's our goal for today and tomorrow. We just want to identify, is the slope positive, negative, 0, or undefined. Okay, and you can keep coming back to these examples to look to see what type of slope they are. And eventually what we're going to do is, even though we know the exact slope of these two, we're going to figure out how to calculate the numerical value of each of those slopes. But again, just for today and tomorrow, we are going to just take a look at some lines and determine if they're positive or negative.